Thanks.
Yeah, he's doing whichever pen. Hopefully everyone had a chance to complete their unit circle. Check your answer, see if there's anything that you missed. If there is, then it's okay. Make a note of that. Tomorrow we'll do another practice. Monday we'll do another practice before your quiz. So I think majority of you are, I'm hoping, are feeling pretty comfortable. We've been doing this for a couple of days now. Okay, so we're going to go to page 32, but I want to point out a couple of things here. Looking at the unit circle, I highlighted a few things. I want to review a bit more with reference angle. Reference angles, you guys showed that knowledge on the quiz, but I want to keep reviewing because it's something that is easy to forget about. So reference angle is how far your angle is from the nearest x-axis. So 30 degrees has a reference angle of 30. Right? Anything in the first quadrant is going to be your reference angle, right? So what's the reference angle for 150? Also 30, because the closest x-axis is 180. Anything in the second quadrant, you're going to subtract involving 180 to get to the reference angle, right? So 180 minus 150 is 30. So these both have reference angle of 30, right? Anything in the third quadrant, you're going to either add or subtract from, or you're always involving 180 as well. So if there's 210, you do 210 minus 180, which is 30. So 210 is also reference angle of 30. 330, this is also reference angle of 30 because in the fourth quadrant, you're going to subtract from 360, find the nearest x-axis and subtract. Okay. And then likewise, these angles in green, these measures in green, these all have reference angle of 45 degrees. Because 135 and 180 is 45 degrees. Okay. And then anything in pink here, these are all reference angle of 60 degrees. Now, as a reminder, how do we go about finding reference angles in terms of radians? Okay. So if I'm sitting at 5 pi over 6, okay, and here's the review. Sometimes, you know, if you have the unit circle, it's easy to know which quadrant you're in, but as a reminder, okay, the way you can tell which quadrant you're in, if it's not a special angle and you're in radian mode, is the radian form is you look at the decimal or the fraction in front of pi. Is that fraction between 0 and 0.5? If it is, then that's your reference angle. You're already in the first quadrant. You only have to worry about finding reference angle if you're in the second, third, or fourth quadrant. So anything between 0.5 and 1, if that fractional value is between 0.5 and 1, you know you're in the second quadrant. If you're in the second quadrant, you're going to be subtracting involving pi, right? So pi minus that measure, your reference angle will be between 0 and pi over 2. Any decimal value that's between 1 and 1.5 is going to be in the third quadrant, and you're going to be involving subtracting pi to get to that reference angle. Anything between 1.5 and 2, again, this is all done without the pi in mind. We're doing all this without the pi. Will be in the fourth quadrant. If something's in the fourth quadrant, you'll subtract involving 2 pi. So for instance, 5 pi over 6, you know this is in the second quadrant because 5/6 is more than 0.5, but less than 1. So we know that if I want to find our reference angle, we can find the nearest x-axis, which is pi. So pi minus 5 pi over 6 will be pi over 6, and pi over 6 will be the reference angle here, which is the same thing at 30 degrees. Okay, so let's go to page 32. And let's review how to find each of the trig ratios given unit circle. Okay. So define values of trig functions anywhere on the circle. Determine the quadrant that you're in and the reference angle. Give the coordinates, check signs, and then evaluate the trig function. So obviously, if you have a unit circle in front of you, it's easy to get all that. But this is also a way to find information without having to fill out the entire unit circle. Let's just say you only want to use it first. Let's say you only have some stuff put down for the first quadrant. That's really all you need to find everything else around the unit circle. So let me show you how we can do that. So if we identify our three special angles here, you got 60 degrees, you got 45, and you have 30. You know that the 60 degrees is pi over 3. You know that the 45 degrees is pi over 4. And you know the 30 degrees is pi over 6. Either using the finger method or counting from 1 to 3, you understand that cosine is the x and sine is the y. Everything has a denominator of 2. 1, 2, 3, 1, 2, 3. Something that's helpful is this chart, A, S, P, C. Everything is positive in the first quadrant. Only sine and cosecant is positive in the second quadrant. Only tangent and cotangent is positive in the third quadrant. And only cosine and secant is positive in the fourth quadrant. So coordinates around the unit circle, cosine is going to be matched up with your x value. Sine is going to be matched up with your y value. And what's tangent? Y over x. It's sine over cosine, so it's y over x. What's secant? 1 over x. I don't want you to think of 1 over x like as 1 divided by a fraction. I just want you to think of it as 1 over x as that you're just going to flip your x value. Flip your fraction. Don't try to put it as a complex fraction. It's just that's more work than you need to do. So just flip the fraction and you're there. Cosecant and sine are reciprocal. So if I flip my sine, my y order pair, my y fraction, I have my cosecant. And cotangent will be 1. X over 1. Yeah. So this is it's fine if you want to use unit circle, but I want to kind of talk about how we can find everything we need simply by relying on the first quadrant. Do this again here. Okay, so cosine of 120, first thing is, which quadrant is this in? Quadrant 2, right? 120 is between 90 and 180. Reference angle. We know in the second quadrant, I got to subtract involving 180, so I get 60 degrees. So 60 degrees, you know what order pair you're dealing with. Go ahead and put that down. My order pair in the second quadrant is going to be negative x and the positive y. And now cosine of 120 degrees, I know cosine is the x value, so I can just pull that negative one out. So this is a way for us to get to these special angles without having to fill out the entire unit circle, right? If we can just use the information from the first quadrant and arrive at the other quadrants, it's just faster that way, and that way you don't have to always create a full unit circle just to do some problems, right? Okay, number 2, tangent of 4 pi over 3. Look at that fraction, 4 over 3. Is that less than 1 or greater than 1? Greater than 1, so which quadrant is that in? Third quadrant, right? It's between 1 and 1.5, so you know it's in the third quadrant. You know third quadrant, you got to involve pi, so if I do pi minus 4 pi over 3, I'm sorry, 4 pi over 3 minus pi, my bad. I have a larger angle than 180, so I gotta do 4 pi over 3 first. Find common denominator, 4/3 minus 3/3 is 1/3. You know your reference angle is pi over 3. And pi over 3, you look at your order pair. Your order pair is 1/2 root 3 over 2. Third quadrant, what adjustment do we have to make? Negative, negative. And now you want to find tangent. So tangent, our strategy is we cover up the denominator and we do what? Y over x. So negative root 3 divided by negative 1. Okay, number 3. Sine of 315. Okay, let's think about 315. Which quadrant is 315 in? Quadrant 4. Reference angle, if you're in the fourth quadrant, you know you got to subtract from 360. Reference angle is 45 degrees, so you pick out the order pair for 45 degrees. Fourth quadrant, what's my order pair going to be? X is positive and Y is negative. Okay. So sine is sine the X or the Y value. Y value, so. Okay, number 4. Tangent of 5 pi over 4. Let's focus on that fraction. Don't look at the pi, should look at the fraction. 5 over 4. Which quadrant is that in? Third quadrant, right? 5/4 is greater than 1, but less than 1.5. Third quadrant. Reference angle, I know I have to involve pi, so larger minus the smaller. Reference angle is pi over 4. Pick out the order pair for pi over 4. Quadrant 3, what are my signs going to be? Negative, negative. Tangents. Our strategy is cover up the denominator. Again, y over x. Negative root 2 divided by negative root 2. Cosine 210, 210. Again, in the third quadrant. Oh, sorry. Yeah, third quadrant. Reference angle, we got to involve 180. $30. Let's find the order pair for 30 degrees. Third quadrant, what are my signs? Negative, negative. Cosine is the x value. Last one, tangent of 5 pi over 6, 5, 6. That's less than 1. So which quadrant is that in? Second quadrant, yeah. Got to involve pi if you want to find reference angle. So coordinates. Pi over 6. Quadrant 2, what are the signs? Negative, positive. Tangents, we cover up the denominator and just do y over x. 1 divided by negative root 3. Not quite complete because we want to rationalize, so okay, any questions here? So this is a nice strategy, especially if you know, it's good to have the unit circle in front of you, but later on, if we want to find a quick angle, we don't want to create a whole, unit circle just for one problem or just for two problems, right? We want to kind of get through it quickly, right? If I know what the first quadrant looks like, if I know what the reference angle, if I know what the signs of my order pair is, I can quickly find that without having to complete, spend 5 minutes to complete the whole unit circle. Okay, does that make sense? All right, page 36. Okay, we're getting a little ahead. 1.15 is not hard, but we'll see another way that we can determine ratio if it's not a special right triangle. And then we'll try to get through these 2 pages, 36, 37. If we don't finish it, it's okay. We can finish it tomorrow, and then we can do the next section, and we can start reviewing. So this is okay. So page 36. Let me go through what we're going to do here. It says the given point lies on the terminal side of an angle of theta in standard position. Find the value of the 6 trigonometric functions. All right, we're going to identify the location of the order pair. It's okay if we don't draw to scale, as long as we have our triangle correct. First step, 1, -8. Which quadrant is that going to be in? Order pair 1, -8. Fourth quadrant. Okay, so I'm going to identify that. I'm going to create my triangle in the fourth quadrant. Use as much space as you can. Use the top of this page, because there's going to be a lot of space needed for 5 and 7. Not so much for the other problems. Oh, sorry about that side. Okay, so 1, -8 in the fourth quadrant. Go ahead and draw a coordinate plane. And you're going to draw a triangle in the fourth quadrant. Now, it's important that we draw our triangle in a very specific way. You're going to start at the origin, extend the triangle, and then you're going to have to connect to the closest x-axis. Never involve the y-axis. And your theta is always going to have to be closest to your origin. So these are ways to not draw the triangle. Okay. We don't want to draw it this way. Okay. This way you're drawing it with the y-axis, which is not going to be correct. So make sure whatever triangle you draw that you're always involving the x-axis. You never want to draw it with the y-axis. And second, you want to make sure that your theta is not far away. Your theta is going to be right closest to your origin, okay, or involving your origin. Okay. Next up, let's just go ahead and identify that we know 1, -8 is going to be a point that is in the fourth quadrant, and we've created a triangle that connects to that point. So how do we get there? Starting at 0, we're going to go 1 unit to the right and 8 units down. So we'll say 1, -8. Okay, it's okay to have your x and y value to be positive or negative, but your hypotenuse will always be positive. Okay, hypotenuse is always positive. Okay, we have 2 sides of a right triangle. How can I find that third side? Staggering theorem. Yeah, so a squared plus b squared equals c squared. 64 plus 1 is 65. So root 65. Something that I want to bring up that students brought up was some students were trying to square a -8 and they kept getting a negative number. So I want to point something out about what the calculator is doing so that you're not caught, not doing the right thing. If I want to square -8, if you enter this in the calculator, it's going to give you -64. Because the calculator doesn't know that you want to square -8. It's interpreting it as square 8 and then attach negative at the end. So if you want to square -8, you need to explicitly tell the calculator that you want it to look at -8, which means you need to put the -8 in a set of parentheses and then square it. Otherwise, the calculator doesn't know that you want the negative to be part of the number. So some students were experiencing a negative number when they were expecting a positive, and that threw their answer off. So just keep that in mind. Okay, the way that I do it is I know that a negative squared is positive, so I just put it in as 8 squared. And I just bypass the whole negative because I already knew it's going to be positive. But if you want to square a negative, you've got to use parentheses. Otherwise, the calculator is not going to know. We'll use plenty of space for number 5. So we want to find sine of theta. We want to find cosine of theta. Tangent of theta. Give some space. Secant. Secant. And cotangent. All right, so Katoa sine is opposite over hypotenuse. We want to rationalize the denominator, so we got multiplied by root 65. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. Okay, how do we get to cosecant? Cosecant is the what? Reciprocal of sine. Now, when you do that, my suggestion is, if you want to flip sine, find the one that's the easiest to flip. Find the one that, if it flips, that you don't have to do rationalizing. So I would much rather flip this variation than this one, because if I flip this one, I got to deal with the radical in the denominator, just creating more work. I'd rather flip this one. If I flip this one, my radical is in the numerator, my denominator has no radical, and it's just going to be a much cleaner answer, right? So if you have a couple of options to choose from, try to look ahead and see which one will result in the least amount of work. Secant, you're going to flip cosine, flip the one that is easier to flip. I'll rather flip this one. If I flip this one, my 1 will be the denominator rather than the root 65 in the denominator. Okay, cotangent, I'm just going to flip tangent. Any questions there? Okay, so there's plenty of space. We don't need a ton of space for the other problems so try number 7. Same strategy. Identify which quadrant you're in. Create your triangle in the proper quadrant. The way you draw your triangle, make sure that you draw the triangle with the x-axis, never with the y-axis. That's going to throw everything off. And then your theta is going to be the angle that's right at the origin, or right near the origin. Staggering theorem. It's okay to have x and y be positive or negative, depending on what's appropriate, but your hypotenuse is always positive. This one should be a little bit easier because there's no radicals involved. So once you find the ratio, there's no more work that needs to be done. So try that, and then see if we can continue moving forward. We're going to try to finish up 36 and 37. If we don't finish, it's okay. But after you guys had a chance to try 7, keep going, and then I will follow up with each problem once you guys had a chance to try. All right, check number 7. Make sure you drew your triangle correctly, the third quadrant. Notice that the bottom of the triangle is touching the x-axis, right? We're using the x-axis for a triangle. We don't want to draw it with the y-axis at all. -8 to the left, up 15. So my x is negative, my y is positive. Staggering theorem. Trig ratios. It's also nice to get that confirmation with this ASTC. Right, we're living the second quadrant, so that means second quadrant means only sine is positive, only sine and cosecant is positive. Everything else should be negative. So sine and cosecant are positive. Cosine is negative, secant is negative, tangent is negative, cotangent is negative. So I like to always use this chart to kind of double check myself, right? That we're consistent with what we expect in terms of the signs for each of the trig functions. Okay, let's do 5 more minutes. See how far we can get in 5 minutes. Okay, so number 9. Find the exact value of each trig function if defined, right, undefined. So sine of pi over 2, we look at our unit circle. Order pair is 0, 1. So we take the y value, which is equal to 1. For number 11, if an angle doesn't live inside the region inside our proper range, what can we do to it? Add 360, add or subtract 360, or add or subtract 2 pi, depending on which form you have. So let's worry about getting that negative 180 into something that feels more easier to interpret. Cotangent of 180. What's that going to be? What's the formula for cotangent? X over y. What do you notice about x over y? That's undefined, yeah. Negative 270. Let's work with that angle first. Get a coterminal angle that's easier to read. Cosine is the x value, 0. Pi is within our range. Tangent is y over x. Okay, let's just do 2 more here. Let's do 17 and 19, okay? 17 says, okay, let's not worry about sketching each angle. Let's just find the reference angle just for practice purposes, okay? 135, find the reference angle. Which quadrant is 135 in? Quadrant 2, you know you got to involve 180. Okay, next up, 7 pi over 12. Okay. Try this without a calculator, okay? Is 7/12 between 0 and 0.5 or between 0.5 and 1? Because 6 over 12 is 1/2, right? So 7 over 12 must be a little bit more than 1/2. So we know we're dealing with second quadrant. If you're in the second quadrant, you're going to be working with pi. And 5/12 is safely between 0 and 0.5 pi, so that's our reference. Good. We'll pick this up tomorrow. We'll circle back to filling in the table with minimal information. We'll try to do it without a unit circle, just for future preparation. Go over and get your phone. Exactly.